Hello everyone. In this video we are going to go over lesson number 4, which is the beginning of studying motion. The study of motion involves describing motion, the description of motion, which we call it kinetics, and the study of the cause of motion, which we call it dynamics. In lesson number 4 and 5 we'll talk about kinetics. We are going to learn how to describe motion in terms of speed, velocity, acceleration, position, distance, and displacement, while in lesson 6, 7, 8, and 9 we are going to learn about dynamics, which has to do with understanding the cause of motion. And dynamics will involve understanding the concept of force, energy, and power. So in lesson number 4 we are going to talk about speed, velocity, and distance. And I'll let you read the first part, which has to do with the relation between position and distance, and I'll move right to defining speed. We are all familiar with speed. It's a concrete concept that we sense every day. When you drive your car, you can read the speedometer, and the speedometer will tell you your instantaneous speed, will tell you the speed of your car and everything inside your car, including yourself, in mile per hour, for example. Now, to calculate the speed based on distance and time, all what you need is to divide the distance by the time taken. And we define distance as change in position. Delta here, the symbol, the triangle here, stands for delta, and delta means change in. So change in x over the change in time, the change in the position over the time taken. So for example, if you look at a car going 20 meters each second, then the speed of the car during the first second here is 20 meters, which is the change in the position, divided by the time taken, which is 1 second. So it's 20 meters divided by 1 second, which will give you 20 meters per second. And notice here that the speed of the car is constant, or we call it a uniform speed. While in the second example here, the car traveled 20 meters in the first second, assuming the time is exactly 12 here, or let's call the clock reading. So let's say the clock reading was initially at 12. After 1 second, which is 1 second past 12, the car traveled 20 meters. So what would be the speed of the car during this period, meaning between 12 and 1 second past 12? The speed of the car would be the distance traveled by the car, the change in the position, which is the distance traveled by the car, divided by the time taken, which is 1 second. So it will be 20 meters per second. Now after another second, which means that the clock reading is now 2 seconds past 12, the car has traveled 30 meters. So what would be the speed of the car during this period? 1 second past 12 to 2 seconds past 12. The speed of the car would be the distance, which is 30 meters, over the time taken, which is 1 second, or the change of the time, which is 1 second. And this will yield 30 meters per second. And the same thing for the third second here, where the clock reading will be 3 seconds past 12, and the speed of the car during the third second will be 40 meters over the time taken, which is 1 second, and this will yield 40 meters per second. So you can see here that the speed of the car is not uniform, it's changing. To be more specific, the speed of the car is increasing. How can we find the average speed during the whole trip? To find the average speed, we have to divide the total distance divided by the total time. The total distance is 20 meters plus 30 meters plus 40 meters, which will yield 90 meters, divided by the total time, which will be 3 seconds. So when you divide 90 meters by 3 seconds, this will yield 30 meters per second, and that will be your average speed. Now, one common mistake that the students do is to add the individual speeds and divide them by the total number of speeds. For example, in this case, they will add 20 meters per second plus 30 meters per second plus 40 meters per second divided by 3. And this will yield the right answer. It will give you 30 meters per second. But this is only because those individual speeds have the same weight, meaning all of them were applied for the same period of time, 1 second in this case. In other examples, this might change. And let me give you here a different example. Let's assume the following clock readings. Let's say between 12 and 2 seconds past 12, the car has traveled 60 meters. Let's say between 2 seconds past 12 and 5 seconds past 12, the car has traveled 90 meters. And finally, between 5 seconds past 12 and 10 seconds past 12, the car has traveled 150 meters. What is the speed of the car between 12 and 2 seconds past 12? And what is the speed of the car between 2 seconds past 12 and 5 seconds past 12? And what is the speed of the car between 5 seconds past 12 and 10 seconds past 12? Now to find the speed, which we give it a symbol V, we have to divide the distance by the time, distance over time. And here the distance between 12 and 2 seconds past 12 is 60 meters. Divide by the time taken, which is 2 seconds, and this will yield 30 meters per second. So the average speed between the clock reading 12 and the clock reading 2 seconds past 12 is 30 meters per second in this case. Let's call this one V1. Now let's find the speed between 2 seconds past 12 and 5 seconds past 12. Let's call it V2. And it's the distance, which is 90 meters. Over the time taken, what's the time between 2 seconds past 12 and 5 seconds past 12? The time is 3 seconds. And the answer will be 30 meters per second. So notice here the speed is constant, although you have different distance, but the distance is not the only factor, the time is the other factor. So in the first 2 seconds, the car travels 60 meters. The speed during those 2 seconds was 20 meters per second. In the next 3 seconds, the car has traveled 90 meters, so it traveled more distance, but also it took longer time. So when you divide 90 meters by 3 seconds, it will yield 30 meters per second. Now let's look at the last period here, and let's call it V3. So V3 will be the distance traveled, which is 150 meters, 150, divided by the time taken, and here the time taken will be the difference between 5 seconds past 12 and 10 seconds past 12, which is what? Which is 5 seconds. Time taken is 5 seconds, and if you carry out the calculation, this will give you 30 meters per second. As you see here, the car was going through a constant speed, and again, to find the average speed, you have to take the total distance divided by the time. So the average speed will be 60 plus 90 plus 150, which will give you 300 meters, divided by the total time, which is 10 seconds, because the clock reading was 12 at the beginning and 10 past 12 at the end. So that's a total of 10 seconds, and this will give you also 30 meters per second. Okay, now let's go ahead and do small change here, and let's change the last reading clock from 10 seconds past 12 to 15 seconds past 12. As a result, the speed pertinent to the last stage of the trip here will be 150 meters, the distance, over the time taken, which will be the time between 5 seconds past 12 and 15 seconds past 12, which will change to 10 seconds. So we are dividing 150 by 10, and this will yield 15 meters per second. So note here in this example, the last example, the car was moving with a constant speed in the first 5 seconds, then in the last 10 seconds slowed down to an average speed of 15 meters per second. So now to find the average speed of the whole trip, we take the total distance, which is 300 meters, divided by the time taken, which will be 15 seconds in that case instead of 10, because the time between the clock reading 12 and the clock reading 15 seconds past 12 is 15 seconds. This will give you an average speed of what? Divide 300 by 15, this will give you 20 meters per second. Now let's compare this, and this is the important point here. Let's compare this to finding the average speed by taking the individual speeds and dividing by 3. So if you take the individual speeds here, V1, which is V1, plus V2, plus V2, plus V3, divided by their number, which is 3, equal V1 plus V2 plus V3 will be 30 for V1, plus 30 for V2, plus 15 for V3, and this is in meter per second, divided by their number, which is 3. So basically, you are dividing 75 meters per second by 3, and this will yield 25 meters per second. So notice here the answer that we got by adding the individual speeds and dividing by 3 is different from the actual answer, which is based on the total distance over the total time. And the reason is, when we took individual speed and divided by 3, we assumed that each speed has the same period of time, and that's not correct, because the first speed here, v1, was acting on the car for only 2 seconds, while v2 was acting on the car for 3 seconds. v3, on the other hand, was acting on the car for 10 seconds. So failing to take the time of each speed will yield error. So always go with this equation: total distance over total time. Average speed is the total distance over the total time, and don't use the individual speeds to find the average. Now here's another example. If you are asked to find the average speed of a trip between Tulsa and Oklahoma City that took 2 hours, you will have to divide the total distance that was traveled by the time taken, and that's simply 110 miles, which is the distance between Tulsa and Oklahoma City, divided by the time taken, which is 2 hours, and this will yield 55 miles per hour. In the second question, you are asked to find the average speed of traveling from your home to TCC, assuming the distance is 4 miles, that it takes you 10 minutes to make the trip. To find the average speed, you have to divide the total distance by the time, and here you are asked to find the answer in miles per hour. So to do that, you have to make sure that the distance is in miles and the time is in hours. Now the distance here is given in miles, which is 4 miles. So the distance is 4 miles. But the time is given in minutes, so you have to convert minutes to hours. To do that, you have to multiply by the conversion factor that has minutes in the denominator and hour in the numerator, and we know that we have 60 minutes in 1 hour. So basically you are dividing 10 by 60, minutes will cancel out, and this will give you 1/6 of an hour. 10 over 60 is 1/6. You can plug 1/6 here, and 4 over 1 over 6, this is basically 4 times 6, and this will give you 24 miles per hour. So the average speed in that case is 24 miles per hour, meaning if it takes you 10 minutes to travel 4 miles, your average speed during those 10 minutes is 24 miles per hour. Okay, the concept of velocity is important, especially when we study acceleration in the next lesson, because acceleration is defined in terms of velocity, not speed. When we talk about one-dimensional motion, and in this class we'll focus on one-dimensional motion, we'll not talk about two-dimensional motion like projectiles or three-dimensional motion. Velocity and speed are equal in terms of their value. The main difference is that velocity will have direction. And the reason this is important because this will factor into the definition of acceleration later. We call velocity vector quantity because it has to be specified by a value, which we call magnitude, and direction, while we call speed a scalar quantity because all what you need is a value. So what's the difference between scalar quantities and vector quantities? Scalar quantity is expressed by a magnitude only, while a vector quantity requires both magnitude and direction. What do we mean by magnitude? A magnitude is composed of numerical value and unit. So basically a number and a unit. Like when we say the speed is 50 miles per hour. This is a numerical value and a unit, which is a magnitude. Vector quantity should have a magnitude, so velocity is a vector quantity. The velocity is 50 miles per hour. This will be the magnitude of the velocity. We have to include the direction as well. So 50 miles per hour, for example, north, or let's say 30 miles per hour southwest, or to the right, or to the left, or up or down, or 50 degrees southwest. All those are ways to express direction. What are the quantities that require only a magnitude? Mass, for example, when you say the mass is 50 kilograms, the time is 50 seconds or 3 hours. Mass and time are expressed only by a magnitude, they are not expressed by direction. Also, distance, speed, energy, power, all those are scalar quantities. Vector quantities like velocity, displacement, which is the vector quantity of distance, acceleration, force, those quantities are expressed by magnitude and direction. Sometimes you'll be asked to find the magnitude of the vector quantity, like when I ask you calculate the magnitude of the average velocity or the magnitude of the force. If I ask you to find the magnitude only, you just need to evaluate the numerical value and the unit. And as I mentioned, this is important in the next lesson when we talk about acceleration. Very important here to realize that scalar quantities can change by changing the magnitude. Vector quantities can be altered by changing the magnitude or the direction. So for example, if you are driving your car at speed of 50 miles per hour and you are going north, so your velocity is 50 miles per hour toward the north, and let's say you made a turn to the right, which altered your direction. So now instead of going 50 miles per hour toward the north, you are still going 50 miles per hour but toward northeast. Did the velocity change? Yes, it changed. Did the speed change? No, it did not change. The speed is still 50 miles per hour, but your velocity has changed from 50 miles per hour toward the north to 50 miles per hour toward northeast. Changing velocity could include changing the magnitude or the direction, or both. As an application of what we talked about regarding to the difference between vector quantities and scalar quantities is this example. You have a red car that is moving to the left, the blue car is moving to the right, and they have the same speed, 30 miles per hour. And you have a pedestrian who's moving at speed of 3 miles per hour. So the question is, does the blue car have the same velocity as the red car? And the answer is no, because the red car is moving to the left, the blue car is moving to the right, hence they have different directions. And since velocity is a vector quantity, you have to share both magnitude and direction in order to have the same velocity. Does the blue car and the red car have the same speed? Yes, they do. They have the same speed, because speed is a scalar quantity. It depends only on the magnitude. It does not depend on the direction. And since both cars are moving with the same speed, which is 30 miles per hour, therefore they have the same speed. How about the pedestrian here? Is he sharing the same speed, velocity, direction with either car? He's only sharing the direction with the blue car. Both of them are moving to the right, but of course his velocity is different from the velocity of the blue car because the speed is different. The blue car is moving with 30 miles per hour, the pedestrian is moving with 3 miles per hour. So they have different speeds and hence they have different velocity. So for the velocity to be equal, the two objects have to share the same speed and the same direction. If you go to the example of the trip from Oklahoma City to Tulsa, you have to determine the direction in addition to the magnitude of the velocity. It will yield 55 miles per hour as magnitude and southwest as direction. If you look at the rest of the discussion exercises, and for example question number 6, what's meant by the time rate of change of position? When we talk about time rate of anything, we are talking about this thing divided by time. So time rate of the flow of fluid means the quantity of the fluid divided by the time taken for it to flow from one point to another. So time rate of change of position means the change in the position divided by the time taken, and we know that the change in the position is distance, so basically it's distance over time, and this is the definition of speed or magnitude of velocity. In the homework here, possible unit of speed. Speed is distance over time, so it has to have unit of length over unit of time. Any unit of length divided by unit of time could be a unit of speed, like kilometer per hour or miles per hour or foot per second or yard per minute. All those are possible units of speed. So the only one that has unit of length over time is a meter per second. In question number 6, you are given the distance traveled 630 miles, and you are given the speed, which is 55.3 miles per hour. You are asked to find the time in hours. How many hours? So we need to rearrange the equation to find the time. We know that speed is distance over time. So here, if we put it in the form of equation, we know the speed is equal to the distance over time. Now in this problem, you are given the speed, v, and you are given the distance. This is the distance, d. So how can we find the time? We know from math, when you have y equal to x over z, and you want to solve for z, z will be equal to what? Z will be equal to x over y. Right? So here, to find time, using the speed and the distance, the time will be distance over speed. You can think about it here as a pi. The distance is on the top, and then here you have v and t. So if you want to find v, you hide v, and it will give you distance over time. If you want to find distance, you hide the distance, and distance will be v times t, the speed times the time. If you want to find time, you hide the time, and it will be distance over speed. So basically, we are dividing 630 miles by the speed, which is 55.3 miles per hour. Now notice here that mile will cancel out with mile, and you get the answer in hours. So if you carry out the calculation, this will yield 11.4 hours. So it took those students 11.4 hours to make it to Florida on spring break. To be more specific, you can convert 0.4 hours to minutes by multiplying 0.4 by 60, which will yield 24 minutes. So basically, it took the students 11 hours and 24 minutes. And that will bring us to the acceleration, which will be the topic of our next lecture. Thanks for watching this video. Please let me know if you have any questions.